All right, everyone, let's multiply. And this time, we're stepping it up with our factors. So let's look at our first one. We have a factor of 3. Okay, so this one's called the threesome. You see it? It's 3 monkeys. So if we have 3 monkeys, we're going to think of it in a smart way. 3 as easy as can be. If you triple what you see. In other words, just add it thrice. That means 3 times. This simply is 1 more than twice. So see that? We have 2 monkeys, but then we have 1 more. So let's say we have a factor of 3 right here, right? So we have 3 groups of what? We have 3 groups of 9. So each one of these monkeys wants 9 scoops of ice cream. How many total scoops of ice cream is that? Well, let's check out. We could write this as 9, 9, and 9. How many times did 9 show up? 3 times. And you could add it 1 by 1 by 1. Or you could think of it in a smart way, which is how they're explaining over here. This simply is 1 more than twice. Do you see where the double is? Boom. We have a double showing up right here, and doubles are our favorite. So let's check and see what this looks like on an array. So we're looking at, and I'm using a Math Learning Center app. Let's look at a 3 by 9. I'm going to make that. So here's my 3 by 9. Now to think of it smartly, instead of seeing 9s showing up 3 times, we can look at it and split that 3 up in a different way, decompose it into 2 groups of 9, which is our double, and then 1 more group of what? 1 more group of 9. So the double of 9, that's why we need to know our doubles. Double of 9 is what? Say it out loud, 18. And then we add on 1 more group of 9. So let's do that here. Our double of 9 is 18. So we didn't have to start 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You just know that. You want to know that double. And then add 9 more. Well, instead of going 18 and then 19, 20, 21, 22, you could just say, oh my gosh, 9 is close to 10, 18 and 10 more. That would not be 18 anymore. That would be 20 something. That would be 28. But we don't want to add on 10 more. We only want 9. And 9 is 1 less than 10. So I'm going to go 1 less than 28, and that would be 27. Okay? So we're thinking smart with our 3. We're going to think it's 1 more than twice. Get that double and add on 1 more. Okay? All right, let's go to our next factor of 4. So check it out. This one's called 4 eyes. See it? We have 4 eyes. These guys down here. 4 is very fast to do. When you multiply by 2. By 2? Let's see what it means. Here's a little good advice. Please, just always double twice. Oh, so you're not just doubling once, you're doubling twice. And we kind of see that here. His eyes, right? 2 of them. And then we have his other ones covered up here. But we have 2 of them. So let's check this out. We have a factor of 4. And what do we have a factor of 4 of? We have 4 groups of 7. So we have 7, 7, 7, 7. 7 showing up 4 times. Okay? So we could add that 1 by 1, or we could think smartly. Okay? And we think, okay, we can just double it twice. What does that mean? Where do we see that? Well, 7's being doubled here. There's the double. We have 2 of them. And oh my gosh, it didn't just show up once. The double showed up 2 times. You see that? Double, double. Okay? So let's look at it in our partial product app. So I'm going to type this in. Instead of a 3 by 9, we're looking at a 4 by 7. And there's my 4 by 7. But instead of seeing this 4 as a whole 4, I'm going to split it up into 2 and 2. because now I see a double of 7 and then another double 7. So if I just decompose that 4 into 2 and 2, I can think smarter and I can say, well, double 7, that's what? Boom, that's another double. Double 7 is 14. And then I just have another of that double 7. I have the double double, okay? Which is why they're saying 4 eyes instead of just 2. Doubled it. So 14 and 14 will give me my product of 28. All right, I'm going to do 2 more factors. Let's check out the factor of 5. This one's called 5 alive. 5 will yield the right amount if by 5s you always count. So I could go over here and I have a factor of 5. And I could say, oh, it's a factor of 5. Oh, I love 5s. I love counting by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And you get so excited, you just keep counting. Well, you have to stop. You have to stop when you get to that 8th count of 5. So I go 5, count with me. 10, I can't hear you. 15, 20, 25, 30, 35, 40. Hopefully you stopped because that was 8 times. Okay, so I could count by 5s to get this answer. Or, this is another favorite method of mine, just multiply by 10. But you might say, well, wait, it doesn't say multiply by 10, it says multiply by 5. Oh, well, why would you do that? Because then you can do this. You can take half of what you get, okay? So if I have a factor of 5, I can say, oh, well, I like 10 even better. Like that is my love. I love 10. And 5 is half of 10, so I'm going to work with 10. So 10 times 8, well, I know 10 times 8 because that just means 8 tens. And I can use place value to help me. 8 tens is 8D. But then, since 5 is half of 10, and I need to get back to this answer, if 10 times 8 is 80, then I need to take half that, since 5 is half of 10, and get my answer to this one. So, well, when I look at this, 8, half of 8 is not 1. It's 4, so half of AD is 4D. Cha-ching! So you can count by 5s, or you can use the strategy of multiplying by 10 and getting half of it. All right, let's check out one more factor. We have a factor of 9. Oh, another one of my favorites. Okay, 9. 9 ball, it's called. They're on a pool table. And why? Well, let's read on. 9 is faster to compute if at first you overshoot it. What does that mean? Well, you overshoot the ball, right? That's going to help you. What does that mean? Here's a very clever tack. Do 10 times and then subtract. Oh my gosh, we're going to use 10 again. Why 10? Because 9 is so very, 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 very close to 10. Oh, and 10s are just so nice because you can get the answer in less than like 2 seconds. 10 times 7 is the same thing as 7 tens. And using place value, 7 tens would just be 7 with a 0 at the end. So if 10 times 7 is 70, then we can figure out 9 times 10. Or not 9 times 10, 9 times 7. So what do? Well, 9 is 1 less than 10. So we need to take away what here? Not just 1. We have to take away 1 set of this, 7. Because here is what we actually did. Let's see it in an array. So I'm going to go to 9 groups of 7, 9 by 7. Boom, that is a lot, right? 9 by 7. Whoa, that's a lot to count. Well, we're saying, well, let's make it easier. Let's go to 10 groups of 7. If we make this 10 groups of 7, now I'm going to say, well, we didn't want 10, we only wanted 9. So watch what I'm going to do. I'm going to make this so that I see my 9. Okay, so I have 9 and 1 more is 10. We want this chunk, okay? But we know that this whole thing is 70 because 7 times 10 is 70. So we need to take away this chunk down here. We need to take away how many? Not just one, we need one set of 7. So if I take out one set of 7 and I go back 7. So if you think on a number line, I'm at 70, I need to go back 7. So if I go back 10, I'm at the lovely tens number of 60, but I don't want to go back 10, I only want to go back 7. So think about that, 7 and how many more is 10? So I'll be at 63. That's why our tens facts are good to know. 3 and 7 is 10. So my answer here would be 63. And the cool thing with factors of 9 is that my answer, if I add up these two digits, 6 plus 3, I'll always get 9. Isn't that so cool? So I can always make sure that my answer is right. My digits will add to 9. All right, we did some tough factors today, okay? We looked at factors of 3, 4, 5, and 9. All right, these take practice. So practice those strategies and let's get smart and efficient at those. All right, practice, 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 practice. All right, multiple.